Hello everyone, Dennis here. In this video, I will talk about GCE O Level Additional Mathematics October-November 2019 paper. Subject code is 4047, paper 2. This video is brought to you by Ace with Dennis. Now, learning can be smart, not hard. Don't forget to subscribe and press the bell notification button to stop missing out free lessons from me. Question 1. Part 1. Differentiate x squared ln x with respect to x. 2 marks. Here's how we differentiate. We'll write d over dx bracket x squared ln x. Notice that we can apply product rule where the u is x squared, the v is ln x. And we'll get d over dx x squared times ln x plus d over dx ln x times x squared. So when we differentiate x squared, we get 2x. When we differentiate ln x, we get 1 over x. And the result will be 2x times ln x plus 1 over x times x squared. Then we simplify, we get 2x ln x plus x. Part 2. Hence find integration of x ln x dx. 3 marks. When we see the question with the word hence, usually we have to use the answer from the previous question. Therefore, here's a solution. We can start with the answer from the previous question, which is d over dx x squared ln x equals 2x ln x plus x. Notice that we want to integrate x ln x, so this is the part that we want to make it to be the subject. So what we can do is, we can integrate both sides for this equation. We get integration of d over dx x squared ln x dx equals integration of 2x ln x plus x dx. So from the left hand side, if we integrate something with differentiation, we get back the same thing. Therefore, it will be x squared ln x. For the right hand side, since this is an operation of plus here, we can split these two terms separately and integrate them separately. So we have integration of 2x ln x dx plus integration of x dx. If we integrate x dx, we get x squared over 2. And for this term, integration of 2x ln x dx, we can factorize the constant 2 outside. We get 2 integration of x ln x dx. Hence, the whole equation becomes x squared ln x equals 2 integration of x ln x dx plus x squared over 2. Then we make 2 integration of x ln x dx the subject. We get x squared ln x minus x squared over 2. It is followed by, we divide 2 for both sides. We have integration of x ln x dx equals half x squared ln x minus x squared over 4 plus c. And this is the answer. That's what the question is asking. Question 2. Part 1. Prove that sin theta over 1 minus cosine theta minus 1 over sin theta equals cotangent theta. 4 marks. Here's the solution. For this question, we'll start from the left hand side, which is sin theta over 1 minus cosine theta minus 1 over sin theta. Then we can combine these two fractions to become one single fraction. Then we get sin squared theta minus bracket 1 minus cosine theta over bracket 1 minus cosine theta times with sin theta. So we can expand the bracket. We get sin squared theta minus 1 plus cosine theta over 1 minus cosine theta times sin theta. Sin squared theta minus 1 is equal to minus cosine squared theta based on the basic identity formula. Hence, it becomes minus cosine squared theta plus cosine theta over 1 minus cosine theta times sin theta. We can factorize the cosine theta. We get cosine theta bracket negative cosine theta plus 1 over 1 minus cosine theta sine theta. Then we can cancel out 1 minus cosine theta from the top and the bottom. And it will be left with cosine theta over sine theta, which is cotangent theta. Hence, proven. Part 2. Hence, solve the equation sine theta over 1 minus cosine theta minus 1 over sine theta equals 3 tangent theta for the range of theta from 0 to 180 degrees. 3 marks. And here's the solution. Again, hence this question with the words hence, we can use the answer from the previous question. So we start with the equation given, which is sine theta over 1 minus cosine theta minus 1 over sine theta equals 3 tangent theta. We know that this part will be cotangent theta. So equation becomes cotangent theta equals 3 tangent theta. Cotangent theta is 1 over tangent theta, then equals 3 tangent theta. And the equation becomes 1 equals 3 tangent square theta, where tangent square theta equals 1 over 3. So tangent theta will be plus minus 1 over square root 3. So we can solve this equation by first finding the basic angle, which is inverse of tangent 1 over sec 3, and the answer is 30 degrees. So the range of the theta that we need to find is from 0 to 180 degrees. So the theta will be 30 degrees and 180 degrees minus 30 degrees, or the theta is 30 degrees and 150 degrees. This is the answer. Question 3. Show that x minus 1 is a factor of x cubed plus x squared minus x minus 1. 1 mark. And here's the solution. So first step is we need to let fx equals x cubed plus x squared minus x minus 1, because we can apply the factor theorem in this question. And we also let x minus 1 equals to 0, and x will be 1. So we substitute x into 1 into fx, which is f1 equals to 1 cubed plus 1 squared minus 1 minus 1. And the answer is 0. So it satisfies factor theorem, and hence we can make the conclusion that x minus 1 is a factor, hence shown. Part 2. Express 4 over x cubed plus x squared minus x minus 1 as the sum of 3 partial fractions. 7 marks. So you can notice that at the denominator x cubed plus x squared minus x minus 1 is this expression. Alright, so the solution is, first we want to try to factorize the denominator. So we already know one of the linear factor is x minus 1. Hence, we can find the quadratic factor. There are two ways. Either we can use long division or we use synthetic method. So to make the calculation easy, I just use synthetic method. Of course, you can use long division method if you want. So this is what we do. 1 we put here, and then we copy down all the coefficients of this expression. So we have 1, 1, minus 1, minus 1. Right? We copy down the 1. So 1 times 1 we get 1. And we add these two numbers together. 1 plus 1 we get 2. Then the next step, 1 times 2 we get 2. So negative 1 plus 2 we get 1. Again 1 times 1 we get 1. So negative 1 plus 1 we get 0. So this number must be 0, so that x minus 1 is a factor. Hence, I can write this expression 4 over x cubed plus x squared minus x minus 1 equals 4 over x minus 1 times x squared plus 2x plus 1, as this is the quadratic factor that we get from the synthetic method here. 1 is for the x squared, 2 is for these 2x, and 1 is for the 1 here. The next thing we can do is factorize the x squared plus 2 plus 1 which we get x plus 1 square. Right? Then it becomes 4 over x minus 1 times x plus 1 square. Next, we can start to write the partial fraction here. So x plus 1 square is a repeated linear factor. Therefore, the whole expression becomes a over x minus 1 plus b over x plus 1 plus c over x plus 1 square. Then we want to find the value of a, b, and c. So it will be 4 equals a times x plus 1 square plus b times x plus 1 times x minus 1 plus c times x minus 1. So basically, this how we get this expression is by combining these three fractions together again, right? So the a will have to times with x plus 1 square because the denominator for a is only x minus 1. For b, it has to multiply with x minus 1 and x plus 1 because it doesn't have x minus 1 and it only has the 1 unit of x plus 1. For the c, it doesn't have x minus 1, so it has to multiply with x minus 1. So the next step is we can start to find the values of this a, b, and c. So first I will let x equal 1 because when I let x equal 1, I can eliminate b and c. Okay, because here 1 minus 1 will get 0, here 1 minus 1 will get 0, then b and c will be terminated. So we get 4 equals a times 1 plus 1 square. So a equals to 1. Next, I let x go to negative 1 because when x is negative 1, the b will be eliminated. Because here minus 1 plus 1, so if we get 0, so the whole term will be 0. Alright, then it becomes 4 equals c times negative 1 minus 1. Alright, yeah, I forgot to mention when x goes to negative 1, a is also terminated because here minus 1 plus 1 is 0. Right, then we can find the value of c, which is c equals to negative 2. We already know the value of a and the value of c. So now we can just substitute any value for the x to find the value of b. I will choose to let x go to 0 because it will make my calculation easy. Hence, for this case, it becomes 4 equals 1 minus b plus 2. I solve this equation, I get b equals to negative 1. Hence, this partial fraction will be equals 1 over x minus 1 minus 1 over x plus 1 minus 2 over x plus 1 square. Question 4. A. Solve the equation log 2x plus log 16x equals negative 2.5. 3 marks. Here is the solution. First of all, given this equation log 2x plus log 16x equals negative 2.5, the very first thing that we need to do is we check the base number of this log. So these two logs, they have different base. The first one is base 2 and the second one is base 16. So we have to make them to have the same base by applying the changing the base law. Usually, we'll choose the lower base as the standard base, or we'll choose the prime number. So for this case, we can write it as log 2x plus log 2x over log 216 equals negative 2.5. Hence, log 2x plus 1 over 4 log 2x equals negative 2.5. And now, they have the same similar terms here. So we get 5 over 4 log 2x equals negative 2.5, which means log 2x equals negative 2. Then we apply anti-log law, we get x equals 2 to the power of negative 2, and the answer for x is 1 over 4. Question 4. It is given that log z minus log y equals log z plus y. Express z in terms of y. 3 marks. 2. State the range of values of z and explain clearly why the range of y is from 0 to 1. 2 marks. is the solution. For the first one, log z minus log y equals log z plus y. So we can combine log z minus log y together, which we get log z over y equals log z plus y. And now, since both sides have the same log with the same base, then we can compare the content inside the log, which is z over y equals z plus y. Then the y move to the right hand side, we get yz plus y squared. And we move the term with z to the left hand side, we get z minus y minus z equals y squared. Factorize the z, we get z bracket 1 minus y equals y squared. Hence, z equals y squared over 1 minus y. 2. From the original equation, log z minus log y equals log z plus y, we can see that z must be greater than 0 and y must be greater than 0 because the log inside the body of the log cannot be a negative value. Similarly, z plus y also must be greater than 0. From the equation that we get just now, z equals y squared over 1 minus y, we can see that the y squared is a positive value. Since z must be greater than 0, 1 minus y must be greater than 0 as well. Alright, for z greater than 0. Therefore, y is less than 1. Therefore, the range of the y is from 0 to 1. Question 5. Fx is such that f double prime x equals 3 cosine 3x minus 4 sine 2x. Given that f0 equals 0 and f pi over 2 equals pi over 6, show that f pi over 3 equals 1 plus square root of 3 over 2. 9 marks. Alright, so before I show you the solution, look at the equation given. F double prime x equals to this one, and we have f0 and f prime over 2, so obviously we have to get the fx from f double prime x, which means that we will have to integrate f double prime x 2 times. Okay, now let's see the solution. For f prime x, it is integration of this f double prime x. Then we get integration of 3 cosine 3x minus 4 sine 2x dx. And we get sine 3x plus 2 cosine 2x plus k. Next, to get fx, we have to integrate f prime x, which is integration of sine 3x plus 2 cosine 2x plus k. When you integrate, we get fx equals negative cosine 3x over 3 plus sine 2x plus kx plus c. The next thing we need to do is we want to find the constants. So given that f0 equals to 0, then we substitute the values inside the equation of fx. We get minus 1/3 cosine 0 plus sine 0 plus k0 plus c equals to 0. Do note that cosine 0 is not 0. Then we get c equals 1 over 3. We use the second information given to find the value of k. So given f pi over 2 equals 5 over 6, then we substitute the values into the equation of fx again. We get negative 1/3 cosine pi over 2 plus sine pi over 2 plus k pi over 2 plus 1/3 equals 5 over 6. We solve this equation. We get 0 plus 1 plus pi over 2k plus 5 over 6 minus 1/3, and k equals 1 over pi. Therefore, we can rewrite the equation of xx to be negative 1/3 cosine 3x plus sine 2x plus 1 over pi x plus 1 over 3. Now, we can find the value that they want us to prove. Find out f pi over 3. So, we'll get f pi over 3 equals negative 1/3 cosine 3 times pi over 3 plus sine 2 pi over 3 plus 1 over pi times pi over 3 plus 1 over 3. We simplify, we get negative 1/3 times negative 1 plus 3 over 2 plus 1/3 plus 1/3, which eventually we get the answer that they want, which is 1 plus 3 over 2. Hence shown. Question 6. A tangent to a circle at the point 5, 5 passes through the origin. The line with equation 3y equals x plus 2 is a normal to the circle. 1. Showing all your working, find the equation of the circle. 7 marks. Here is the solution. Given that the tangent passes through the origin, hence the equation of tangent will be y equals mt x, where mt is the gradient of the tangent. From the coordinates of 5, 5, we can substitute x equal to 5 and y equals to 5 into the equation. We get 5 equals mt times 5, which means mt equals 1. Next, therefore, the equation will be y equals 2x. We also know that the gradient of tangent multiplied with the gradient of normal will give us negative 1, which means that the gradient of the normal is negative 1. Therefore, the equation of normal at the coordinates of 5, 5 is y minus 5 equals negative 1, x minus 5, which means y equals negative x plus 10. So this is the equation of the normal. The center of circle is at the intersection point of the normals. So 3y equals x plus 2. Then we make y the subject. It is 1 over 3 x plus 2 over 3. So the equation of the first normal, I label it as the first equation. And this is the second equation. We equate these two equations together. Equation 1 equals to equation 2. We get negative x plus 10 equals 1 over 3 x plus 2 over 3. So we get 4 over 3x equals 28 over 3. And the answer for x is 7. Therefore, we find the value of y, which is negative 7 plus 10, and it is 3. So this is the coordinates of the center, which is 7, 3. And now, I want to find the radius of the circle, which is square root of 7 minus 5 square plus 3 minus 5 square, which is get from the length of the line from point C to the coordinates of the point 5, 5. So I get r equals to square root of 8. Now I can form the equation of the circle, which is x minus 7 square plus y minus 3 square equals 8. Part 2. Find the coordinates of the point on the circle which is nearest to the x-axis. 2 marks. Here is the solution. From the previous question, we know that the coordinates of the center is 7, 3, and the radius is square root 8, which is less than 3. Which means that the circle is completely above the x-axis. We can sketch the graph to see the whole picture clearer. So this is the x-axis, and this is the circle with the center C at the coordinates of 7, 3. And this is the radius, which is 8. So this point is the point which is nearest to the x-axis. it is the lowest point of the circle. And from this diagram, we can see that the coordinates of this point is 7, 3 minus 8, which is 7, 3 minus 2, 2. Question 7. Part 1. Sketch the graph of y equals modulus x squared minus x minus 6, showing the coordinates of the points where the curve meets the axis. 5 marks. So what it means by to show the coordinates of the points where the curve meets the axis, it means we need to find the x-intercepts and the y-intercepts. Right, so here's the solution. Given the equation y equals modulus x squared minus x minus 6, we can factorize the equation, which we get y equals modulus x plus 2 times x minus 3. Now, we want to find the y-intercept, which means when x equals to 0, y will be 6. When y equals to 0, the x will be negative 2 and 3. This is the x-intercept. Next, we want to find the x-coordinate of the stationary point. For this case, it is minus 2 plus 3 over 2. So we are actually get the values of the x-intercepts and divide by 2 because the x-coordinate of the stationary point will be at the center of these 2 points. And we get half. Then we move on to find the y-coordinates of the stationary point by substituting the value of x equals to half into the equation. We get modulus half plus 2 times half minus 3. And the value is 6 and 1 over 4. Now, we have all the information that we need, so we can start to sketch the graph now. We can start with the x-axis. So this is a smiley face as the x squared is a positive x squared. Notice that I draw a dotted line below the x-axis as this is a modulus function. So it will reflect above the x-axis, which looks like this. And we know that this point will be negative 2 and this point is 3 as they are the x-intercepts. Next, this is the stationary point, which is half and 6 and 1 over 4. From here, we can draw the y-axis, which is at this location, and the y-intercept will be 6. So this is the graph that we need to sketch for this question. Alright, now we have the graph of the equation for this question, right? The question is a line with an equation of the form y equals k minus 3x is a tangent to the curve y equals modulus x squared minus x minus 6 at the point where x equals 2. Part 2. Show that k equals 10, 2 marks. And hence, add a sketch of the graph of y equals modulus k minus 3x to your diagram in part 1, 2 marks. Alright, so here's the solution. Since the line is the tangent to the curve at x equals to 2, so we can equate these two equations together. So k minus 3x equals modulus x squared minus x minus 6. So we substitute x equals to 2 inside this equation. We get k minus 3 times 2 equals modulus 2 squared minus 2 minus 6. We solve this equation. We get k minus 6 equals 4. Hence, the k value will be 10. So, shown. Part 3. We can now sketch this linear graph with modulus function y equals modulus 10 minus 3x. So, firstly, we want to find the y-intercept. So, when x equals to 0, y equals to 10. And next, we want to find the x-intercept, which is when y equals to 0, x equals to 3 and 1/3. And now we can plot these 2 points. This is the y-intercept, which is 10, and this is the x-intercept, which is 3 and 1/3. Right? We can draw this linear line, which looks like this. And notice that when it passes through below the x-axis, we will reflect it above the x-axis as it is a modulus function. And we put the dotted line for the part which is below the x-axis. Question 8. The speed v meters per second of a vehicle t seconds after passing a fixed point O is given for t greater than 0 by v equals ae to the power of t over k minus 3, where a and k are constants. The table below shows corresponding values of t and v. So here's the table. The first question, draw the graph of ln v plus 3 plotted against t using a scale of 1 cm for 1 unit on the t-axis and a scale of 5 cm for 1 unit on the ln v plus 3 axis. 3 marks. 2. Use the graph to estimate the value of each of the constants a and k. 5 marks. 3. State the speed of the vehicle at O. 1 mark. 4. Explain how the graph could be used to find the value of t when the speed of the vehicle is 5 meters per second. 1 mark. 5. Use your values of a and k. Calculate the value of t when the vehicle comes to rest. 1 mark. Alright, now let's answer the first question. To draw a graph of ln v plus 3 plotted against t using a scale of 1 cm for 1 unit on the t-axis and a scale of 5 cm for 1 unit on the ln v plus 3 axis. 3 marks. Before we want to draw the graph, first we have to calculate ln v plus 3. So we have to calculate one by one by substituting the value of v individually. So the first v will be 6.35, then we get 2.24. The second point, the v is 4.38, then we get 2. Next, 2.67, we get 1.7274, and the last one, 1.41, we get 1.48. And now we can start to sketch the graph using the scale given. So here's the x-axis, which is t, and here's the y-axis, which is ln v plus 3. So this is the origin, 0. And we follow the scale. So it is for the t-axis, it is 1 cm for 1 unit, which means that 2 cm is 2 units. Hence this is 2, 4, 6, 8. And for the ln v plus 3 axis, it is 5 cm for 1 unit. So which means that this is 1, this is 2, and this is 3. Alright, now the first point is t2, ln v plus 3 is 2.24, which is at this point. And then followed by the next point, t is 4, ln v plus 3 is 2, which is at this point. The next point will be here, and the next point will be here. So once we finish plotting all the points, then we connect them with a straight line. So this is the graph for part 1. Next, for the second question, use the graph to estimate the value of each of the constants a and k. 5 marks. So the first thing we need to do is we need to find the gradient of the graph, which is m equals y2 minus y1 over x2 minus x1. Right? We can find we can use the point of any 2 points from the data here. So let's choose this point and this point. So the gradient will be 1.48 minus 2 over 8 minus 4. And we get negative 0.13. Okay, so this is 2.5. So which means C is 2.5. The equation of line will be ln v plus 3 equals negative 0.13 t plus 2.5. So this is based on the linear law. The y-axis is ln v plus 3 followed by mx plus c. So this is the y equals mx plus c. The gradient is negative 0.13 and the c is 2.5. Then we anti-log this equation, we get v plus 3 equals e to the power of negative 0.13 t plus 2.5. We can split the v terms here to be e to the power of 2.5 times e to the power of negative 0.13 t. And we move the constant 3 to the right hand side, we get v equals to e to the power 2.5 times e to the power negative 0.13 t minus 3. And we compare the equation. Here, v equals to ae to the power of t over k minus 3. We get a is e to the power of 2.5. And the value is 12.2. Rounded out to 3SF. Similarly, 1 over k equals negative 0.13. So here is the 1 over k and the value is negative 0.13. We solve this equation, we get k equals negative 7.69, which has been rounded off to 3SF. Part 3. State the speed of the vehicle at O, 1 mark. So here's the solution. When the vehicle is at point O, the t equals to 0, which is, it will be at this point, which means that ln v plus 3 equals to 2.5. We solve this equation. We get v plus 3 equals e to the power of 2.5, and v will be equals e to the power of 2.5 minus 3, and the value is 9.18. Rounded up to 3 significant figures. 4. Explain how the graph could be used to find the value of t when the speed of the vehicle is 5 meters per second, 1 mark. So here's the solution. As v equals to 5, ln v plus 3 will be equals to ln 5 plus 3, which is 2.079. So from the graph, we find the value 2.079, which is here, and the corresponding t value will be 3.6 seconds from the graph. 5. Using your values of a and k, calculate the value of t when the vehicle comes to rest, 1 mark. So, firstly, we substitute the value of a and k into the equation. We get v equals to 12.1825 e to the power of t over negative 7.6923 minus 3. So, once the vehicle comes to rest, the v equals to 0. This is what we get, 12.1825 times e to the power of t over negative 7.6923 equals to 3. We solve this equation. We get t over negative 7.6923 equals ln 3 over 12.1825. And the value of t will be 10.8 seconds, rounded off to 3 significant figures. Question 9. Given this diagram, The diagram shows part of the curve y equals 8 over 3x plus 2 intersecting the y-axis at point A, 0, 4. The tangent to the curve at the point P, 2, 1 intersects the y-axis at B. Find the exact area of the shaded region, 11 marks. So the keyword for this question is the exact area of the shaded region. Hence, when you give answer, don't give the approximate value. Alright, so here's the solution. To find the area of the shaded region, there are two ways you can find it. The first way is either you look at this curve bounded to the x-axis and then you minus the trapezium here, or you can look at it as the curve bounded at the y-axis, then you minus the triangle here. So the very first thing that you need to do is label this as 2 and this is 1. And we want to find the equation of BP first. So first thing is to get the gradient. From the equation given, y equals 8 over 3x plus 2, we can change it into this form so that we can differentiate easier later. So y equals to 8 times 3x plus 2 to the power of negative 1. Hence, dy over dx will be equals negative 8 times 3x plus 2 to the power of negative 2 times 3. And it is negative 24 over 3x plus 2 squared. So the gradient of the tangent will be dy over dx when x equals to 2, which is negative 24 over bracket 3 times 2 plus 2 squared. And the value is negative 3 over 8. Hence, the equation of the BP will be y minus 1 equals negative 3 over 8 x minus 2, which is y minus 1 equals negative 3 over 8x plus 3 over 4. And it will be y equals to negative 3 over 8x plus 7 over 4. Therefore, the coordinates of B will be 7 over 4 as it is the y-intercept of the equation BP. Next, given that the y equals 8 over 3x plus 2, right? So now I want to make x the subject because I want to look at the graph as it is bounded to the y-axis. So it will be 3x plus 2 equals 8 over y. 3x equals 8 over y minus 2, and x equals 1 over 3 times 8 over y minus 2. Hence, the first area, which is the area under the curve bounded to the y-axis, will be 1/3 integration from 1 to 4, 8 over y minus 2 dy. So after I integrate, I get 1 over 3, bracket 8 ln y minus 2y, bounded from y, 1 to 4. Substitute the values, I get 1 over 3, bracket 8 ln 4 minus 2 times 4, minus bracket 8 ln 1 minus 2, 1. And I get 1 over 3, bracket 8 ln 4 minus 6, which is 8 over 3 ln 4 minus 2. Next, I want to find the second area, which is the area of the triangle. So it will be half times 2 times 7 over 4 minus 1. And the answer is 3 over 4. Therefore, the area of the shaded region will be A1 minus A2, which is 8 over 3 ln 4 minus 2 minus 3 ln 3 over 4. And the answer is 8 over 3 ln 4 minus 11 over 4 units squared. Question 10. The roots of the quadratic equation x squared equals 3x minus 4 are alpha and beta. 1. Show that alpha cubed equals 5 alpha minus 12. 3 marks. 2. Write down a similar expression for beta cubed. 1 mark. 3. Hence or otherwise, find the value of alpha cubed plus beta cubed. 3 marks. Here is the solution. For part 1, since alpha is a root, therefore x equals to alpha. We can substitute this x equal to alpha into the equation x squared equals 3x minus 4, which is alpha squared equals 3 alpha minus 4. alpha cube is A times alpha square. Therefore, it is alpha times 3 alpha minus 4. Expand the bracket, we get 3 alpha square minus 4 alpha. And again, we have the alpha square. So we can substitute the alpha square again with 3 alpha minus 4. Expand the bracket, we get 9 alpha minus 12 minus 4 alpha. Simplify, we get 5 alpha minus 12. For part 2, to get our beta cube is very simple. Just get from the answer of part 1, substitute the alpha to be beta. Therefore, it becomes beta cube equals 5 beta minus 12. Part 3. Alpha cube plus beta cube. So we already know the expression for alpha cube, which is 5 alpha minus 12, and beta cube is 5 beta minus 12. Simplify, we get 5 alpha plus 5 beta minus 24. We can factorize the 5, then it becomes 5 times alpha plus beta minus 24. And from the equation, x squared equals 3x minus 4, x squared minus 3x plus 4 equals 0. A is 1, B is negative 3, and C is 4. So the sum of the roots alpha plus beta is negative b over a, which is 3. Hence, we go back to our equation alpha cube plus beta cube. It is 5 times 3 minus 24, which gives us negative 9. Part 4. Find a quadratic equation whose roots are alpha squared over beta and beta squared over alpha. 4 marks. Here is the solution. From part 3, the equation can be rearranged to be x squared minus 3x plus 4 equal to 0, where a is 1, b is negative 3, and c is 4. The sum of roots alpha plus beta is negative b over a, which is 3. The product of roots alpha times beta equals c over a, which is 4. Now we want to find the sum of new roots, which is alpha squared over beta plus beta squared over alpha. We can combine these two fractions together, which we get alpha cube plus beta cube over alpha beta, and the values is negative 9 over 4, which is negative b new over a new. Next, to find the product of new roots, alpha squared over beta times beta squared over alpha will give us alpha times beta, and the value is 4. This is 16 over 4, and it is c new over a new. Therefore, the a new will be 4, the b new will be 9, and the c new is 16. Now we can form the new equation, which is 4x squared plus 9x plus 16 equals 0. Question 11. Given this diagram, the diagram shows a metal placed in the shape of a trapezium in which angles NKL and KLM are right angles. The lengths of LM and MN are 5 cm and 12 cm respectively. The acute angle KNM is theta radians. 1. Show that the perimeter PCM is given by P equals 22 plus 12 cosine theta plus 12 sine theta. 2 marks. Here's the solution. So the first thing is, this is the dotted line. We label this length as the x and this length as y. We can form a right angle triangle here. So the sine theta will be x over 12. So the KL equals to x, and it is 12 sine theta. Cosine theta equals y over 12. Y is 12 cosine theta. So now I want to find the perimeter, which is Kn plus Nm plus Ml plus Lk. So Kn is 5 plus 12 cosine theta, Nm is 12, Ml is 5, and Lk is 12 sine theta. Then we simplify, we get P equals 22 plus 12 cosine theta plus 12 sine theta. Hence shown. Part 2, find the value of r when 12 cosine theta plus 12 sine theta is expressed as r cosine theta minus alpha, where r and alpha are constants and hence state the maximum perimeter of the plate. 3 marks. So obviously this is to change the expression into the r formula. So here's the solution. Apply the r formula. R equals square root of 12 square plus 12 square, which is square root of 2 times 12 square, and the value is 12 sub 2. Therefore, the parameter will become 22 plus 12 sub 2 cosine theta minus alpha. So the maximum value of cosine theta minus alpha is 1. Therefore, the maximum parameter will be 22 plus 12 sub 2 times 1. And the answer is 22 plus 12 sub 2 cm. Part 3. Show that the area of the plate A cm square is given by A equals 60 sine theta plus 36 sine 2 theta. 2 marks. Here's the solution. So we know that this length x is 12 sine theta and this length is y equals 12 cosine theta. So the area of this trapezium will be half times kn plus lm times x. Just substitute the values here, which is half times 5 plus 12 cosine theta plus 5 times 12 sine theta. Simplify and expand, we get 6 sine theta times cos 10 plus 12 cosine theta. We get the area will be 60 sine theta plus 72 sine theta cosine theta. Applying double angle formula, which is sine 2 theta equals 2 sine theta cosine theta, the area becomes 60 sine theta plus 36 times 2 sine theta cosine theta, which is 60 sine theta plus 36 sine 2 theta. Hence, shown. Part 4. The maximum area of the plate is obtained when the value of theta, which can vary, gives a stationary value of A. Find the value of theta. 5 marks. Right, here's the solution. The area is equals 60 sine theta plus 36 sine 2 theta. So, since the question say that it is a stationary value, so we can differentiate dA over dt. dA over d theta equals 60 cosine theta plus 36 cosine 2 theta times 2. Simplify, we get 60 cosine theta plus 72 cosine 2 theta. To find the maximum area, we let dA over d theta equals 0, which is 60 cosine theta plus 72 cosine 2 theta equals 0. So we divide 12 and we get 5 cosine theta plus 6 cosine 2 theta equal to 0. Cosine 2 theta is 2 cosine square theta minus 1. Therefore, equation becomes 5 cosine theta plus 6 bracket 2 cosine square theta minus 1. Expand, we get 12 cosine square theta plus 5 cosine theta minus 6 equal to 0. So this is a quadratic equation. We can factorize with the brackets. We only can use the formula. Hence, cosine theta equals negative 5 plus minus square root of 5 square minus 4 times 12 times negative 6 over 2 times 12. And we get negative 5 plus 313 over 24, or cosine theta equals negative 5 minus 313 over 24. We calculate the value, we get cosine theta equals 0.52883. And the angle theta is 1.01 radian. And the next one, cosine theta equals negative 0.9455. We reject this angle because the theta is an acute angle. Therefore, the only answer is 1.01 radian. And that's all for this video. Thanks for watching. Do you have any thoughts, opinion, or experience to share? Write it down in the comments. We would love to hear from you. Do you like this video? Please don't forget to like and share to your friends. Until then, see you in the next video. Have a great day ahead.